we'll take a look at how do we separate liquid mixture. Okay, there are actually a total of 3 different methods: fractional distillation, separating funnel, and chromatography. Okay, it all depends on the characteristics of the liquid mixtures that you are dealing with, which will be discussing. Okay, so fractional distillation, okay, sounds very similar to simple distillation, right? In fact, the setup is almost identical as well. Okay, but there is one distinct difference that differentiate them, so I will actually talk about that. Okay, but let's take a look. What's so special about this liquid mixture, right? Whereby we will use fractional distillation to separate it. This liquid mixture is said to be miscible. Okay, and miscible means, okay, they are soluble in each other, and the two or more liquids, okay, they have different boiling points. It's a very important characteristic. Okay, so just to give you an idea about what is miscible liquid, so you see my picture over here, you can see that I have 2 liquids added together, and when they are added together, they seem to mix very well, and it gives you what we call a homogeneous mixture. Okay, you do not see 2 layers, 3 layers. It's just a very cohesive and uniform appearance. So that's what it means by a miscible liquid. Okay, liquid mixture. All right. So one of the classic mixture like that, okay, is actually water and ethanol. Okay, ethanol is an example of an alcohol, and the two of them have boiling points of 100 degrees Celsius and 78 degrees Celsius respectively. Okay, I'll need you to keep this in mind because the next example that I'm going to show you, we are going to be performing fractional distillation on this particular mixture. So clearly you can tell that ethanol has a lower boiling point of 78 degrees Celsius. So it will have an impact on what we see next. Okay, so my mixture of ethanol and water is placed in a round bottom flask again. We still have our thermometer, which will give us the boiling point of the solvent that is distilling over. We still have our condenser, which is going to do its job, okay, of cooling or condensing the hot vapor into a pure liquid. You still have your conical flask or your container to actually collect the distillate. Okay, so nothing is changed, but there is a difference. This setup has an additional feature known as the fractionating column. Okay, now this fractionating column is made up of either glass beads or glass columns, usually, to provide an increased surface area, okay, for continuous evaporation and condensation to take place. Okay, I'm going to explain what is this all about. Okay, so I'm going to enlarge this region, then it will make more sense to you. Okay, so I'm actually let's say we are heating ethanol and water. Ethanol boils at 78 degrees Celsius, water 100 degrees Celsius. So your ethanol being a liquid that is actually having a lower boiling point, it will definitely turn into a gas first. Correct? Okay, so the moment it turns into a gas, it will then start entering the fractionating column. Then it will get into contact with this first column over here. Maybe it's a glass column. Okay, and this glass column is actually quite cool. Okay, so what will happen is this gas will condense, okay, into ethanol liquid, of course, but it will not stay there. It will drop back into your round bottom flask. Okay, but this process, as it continues, right, where more and more ethanol get into contact with the first glass column, it will slowly warm up the glass column until the temperature is pretty high. okay, at maybe 78 degrees Celsius, then it will allow the gas to slowly move up the fractionating column. And then the same repeated evaporation and condensation process occur, and eventually the gas escape. Okay, you might wonder, why must this continuous evaporation and condensation occur? It's because, right, with this repeated evaporation and condensation occurring, it will increase the possibility of better separation between ethanol and water. So your ethanol is given the opportunity to rise up the fractionating column, but water will be held behind. Okay, as water has a higher boiling point, so the chances of water, right, condensing back into the round bottom flask is much higher. Then your ethanol will be able to move on, okay, move up the fractionating column, and eventually gets collected as the first liquid in the conical flask. So the key idea here is, if you have two or more liquids, okay, then the liquid with the lowest boiling point will distill first, and therefore the liquid with the highest boiling point will be distilled last. Okay, if you only have two liquids, then you just need to change the word to lower and higher. Okay, so that is how fractional distillation works. Industrial application, okay, fractional distillation is used for many important industrial processes, okay, around us. All right, one of the classic one would be to obtain petroleum fractions from crude oil. Crude oil is actually the oil that, you hear on the news. Oil prices are rising, blah blah blah, and then oil is found in this country. That's crude oil. So this crude oil is actually sent to a place called an oil refinery. Okay, this is a picture of oil refinery. What you are seeing over here, all these are what we call fractionating towers. So it works like a fractionating column. The only difference is it could be a few stories high, okay, not a small one like in the laboratory. Okay, then we can also use fractional distillation to separate different gases from liquid air, and to ensure that ethanol, okay, is being separated from glucose with sugar solution, so that the ethanol can be used to make wine. Okay, but more will be elaborated next year when we cover chapter 18 and 20 respectively.